Okay, so we're just gonna do a little bit of 8.3, which is on scale diagrams, and then we'll continue the rest of 8.3 next class. So when we work with scale diagrams, basically we're talking about a diagram of an object or a shape or something in which the measurements have been reduced or enlarged. And this is always done proportionally to the actual measurement. So it's not just done as an approximation. This is done by measuring and then scaling, what we call scaling it down. So an example of this would be the floor plan of a house. So we see these in all the new developments they're building, and they show us what the floor plan will look like in a new house. And so when we talk about a scale diagram being either reduced or enlarged, compared to the original, this scale diagram, a floor plan, what is it? So the original has been what? Reduced or enlarged? Hopefully you said reduced, because of course our houses and our floor plans are much, much larger. And you can see down here this 14, that's 14 feet by 16 feet. So this is a scaled down, what we call a scaled down diagram. Okay, and so another example of this would be like a map. A map is scaled down. So the map of Canada is obviously scaled down quite a bit because Canada is very, very large. Here we have another example, and this is an image under a microscope. And so in this case, the original has been what? Reduced or enlarged? Hopefully you said enlarged. And so we say that this is either scaled up, or more commonly, we'll say that this has been magnified. Okay, like a magnifying glass magnifies an image, so magnifying makes it larger. Okay, and so you'll see that both of these are quite common to magnify or to scale down, scale up or scale down. And this is something that we use in everyday life and that we rely on in everyday life. And so it's important to know how we can get between the scaled up or down diagram and the actual thing. So if we're looking at scale factors and ratios, so when you're looking at a map or a photograph, most of the time the image has been scaled down, and we call this a reduction. So like when you look at the image of a lion or a bear in a picture, of course, and we all know this intuitively, that the bear is not really like a couple inches high, right? A bear is very large. So we say that this is scaled down, or it's a reduction. So the picture's been reduced. But when we look at enlargements, so like a picture of a bacterium or a parasite under a microscope, we say the image has been scaled up or enlarged, and we call this an enlargement. So what we always have to do is write out our scale ratio. So in this case, a map has a scale ratio of 1 to 50,000. So our ratio is 1 to 50,000. And this can be any units. Okay, just depends on what you're looking at. So in this case, we're looking at a map. It's probably centimeters, but it depends on what we're looking at. So the ratio does not include the units. And so when we write it out with the units, that's our scale ratio. So 1 centimeter to 50,000 centimeters. But when you look at a ratio, if you were just given a 1 to 50,000 ratio, there's no way you can tell the units from that unless you're told the units. So either they have to have the units included, or you would have to measure them yourself. And so the 1 centimeter would be on the map. So 1 centimeter on the map, or the diagram, or the photo, or whatever you're working with, would equal 50,000 centimeters in real life. So the actual thing. So in terms of a map, if you moved 1 centimeter on the map, you've moved 50,000 centimeters in real life. And so this helps when you're driving or walking, because it just gives you a better scale. So walking, unquote, 1 centimeter on the map is actually walking half a kilometer in real life. We have it written out. For every 1 unit on the map, there's actually 50,000 units across on the land. So 1 centimeter on the map is really 50,000 centimeters in real life. And there's 2 ways we can express scale. So we can give it as a ratio, and the ratio is always given as diagram to real life. And this is a scale of 1 to 20 as an example. Okay, not every diagram to real life is a 1 to 20 ratio. That's just how you would write the ratio. Okay, it could be like 3 to 11 or something like that. Okay, so any ratio, you just have the diagram to real life. Or we can use scale factor. And in scale factor, it's more of a calculation, and so we put diagram over real life or actual. And so if we use this one here, it would be 1 over 20. And then we can calculate that, and that is 0.05. So that's our scale factor. Okay, so you can use the ratio or the scale factor. And again, ratios and scale factors have no units. Okay, so the 1 to 20 could be, it could be applied to any units. Like, we could say 1 meter, a ratio of 1 meter to 20 meters, or a ratio of 1 foot to 20 feet. Okay, so the units just depend on what you're looking at and the information you're given. So that's where we're going to stop here. So you don't have to do anything for 8.3. And so the only thing I would include on a quiz is just sort of understand the difference between an enlargement and a reduction, okay, which hopefully is quite intuitive. So on Tuesday, which is our first day back from the long weekend, we're going to have a quiz. So it's going to be on the 8.1 stuff that we covered on Tuesday, so slope and things like that. There's going to be a conversion question with more than one conversion, and then maybe something on just the idea about scale factor. So you have worksheet 8.2. I'm not going to collect that. I'm going to post the key up later today. And then be sure to work on the textbook questions too. And that's it. And I'll see you on Tuesday. And have a great weekend.